Hi everyone, today I'm going to tell you about the attack which has the header as PHP's Git server hack to add backdoors to PHP source code. Let's start with supply chain. A supply chain attack is cyber attack that aims to damage an organization by concentrating on weaker elements within the supply chain. This attack is also known as a third-party or cost chain attack. When an individual infiltrates your server via outside associate or company with access to your systems and information, an attack occurs. In the past few years, this has significantly altered the attack surface of the average enterprise, with more suppliers and provider organizations touching confidential data than ever before. The risk associated with a supply chain breach have never been greater. It is because of the new types of attack, increased public awareness of the risks, and increased regulatory oversight. Meanwhile, attackers have more resources and weapons than ever before, resulting in massive storm. Latest SolarWinds attack is a good example. The figure shows how the supply chain is being attacked from the delivery side, resulting in a supply chain breakdown due to a cyber attack on an upstream supplier. You can see in the figure the supply chain is targeted from the supply chain's weakness and data is obtained. Backdoors are kinds of malware that permits for remote control of a compromised website via bypassing suitable authentication techniques. Even after updating a website, changing its passwords, and doing other post-hack strategies, the backdoor may not be eliminated. Leaving a backdoor in a site lets you to be accessed suddenly. Even though there are backdoors written in all languages, those we see the most are completed in personal homepage. Backdoors are naturally difficult to find because they do not have to be linked to every page on the website. They do not want to be big, instead they prefer to be small and ignored. Most backdoors are made to be easily confused with non-malicious code. They can be found anywhere in a site's file system or database, and some of them have passwords while others are heavily encrypted and encoded. When looking for a secret backdoor, there are a few problems to consider. To quickly find backdoors on your website, you must first understand all of the files and be familiar with all of their content in order to spot the differences. Plugins can be used to legally use certain features. Be sure to double-check any changes because removing benign features could cause your website to crash. For example, would you consider these codes to be backdoors? The first code allows attackers to run any type of code, add or delete files, and perform other malicious actions. It is easy to miss something when you're looking at hundreds of lines of code. And in the second one, most of the backdoor is hidden inside of an image. Unknown attackers were able to gain access to the PHP project's essential code repository and upload malicious code that inserted a backdoor into the runtime that runs most websites on the internet. The hackers pretend to be high-profile PHP developers, but the code commits were not widely dispersed and were discovered within hours when other developers reviewed them. Open source programming is the heart of many essential internet services, and it makes up most of the code base of the modern applications. The number of supply chain attacks against open source tasks, which are typically run by volunteers with limited resources, has increased dramatically in recent years, and experts predict that this attack vector will grow in popularity among attackers as it is difficult to defend against. A code commit was moved to the PHP source repository on Git PHP.net. The commit was made in the name of Rasmus Lerdorf, PHP's creator and core developer. 2 hours later, another PHP contributor pointed out a typo in the code and another asked what it did. This drew the attention of a security developer who said, "If the string begins with redeem, this line executes PHP code from the inside the user agent HTTP header." The code in the HTTP header was effectively a backdoor, allowing an attacker to execute arbitrary code on any web server running these Trojan-Z versions of PHP by simply sending requests with a specially designed string. The wrong commit in Lidov's name was quickly reverted by PHP core developer Nikita Popov, but Popov's reversion was quickly reverted from what appeared to be his personal account as well. This resulted in a hacker posing as Popov and restating the malicious code. The server was taken offline after a third core developer inverted it and reversed the wrong commit. They don't know yet how exactly this happened, but everything points towards compromise of the Git PHP.net server. Following the attack, the team decided to shut down its personal Git server and move creation to GitHub. According to Popov, since maintaining its own Git infrastructure, which used a homegrown karma scheme to gain access to manage, was unnecessary security danger. The PHP community had been using GitHub as a backup for its self-managed Git repository, but it has now rendered it a primary repository and is migrating all members to the PHP company on GitHub, which needs to be two-factor authentication for money owed. Something he was not aware of at the time was the Git PHP-net endorsed moving changes not only via SSH but also via FTP, infrastructure and public key cryptography provided by Gitolit but also through HTTPs. The latter used Git HTTP backend behind Apache 2 digits authentication against the master PHP-net user database rather than Gitolit. Password-based authentication is much less reliable than public key authentication, so he was not sure why it was ever endorsed. We can deduct from access logs that the commits were pushed using HTTPs and password-based authentication. The figure is an example of appropriate log entries. It is worth noting that the intruder only takes a few guesses at the usernames before successfully authenticating until the right ones discovered. Although they do not have any concrete evidence, it is likely that the master PHP-net user database has been compromised, though it is unclear why the attacker would need to guess usernames in that case. The master PHP-net framework, which is used for authentication and various management activities, was running very old code on an extremely old operating system and PHP version, so vulnerability was not unexpected. So you can see the code commits from the figure, but what does the code commit do? When PHP output compression is enabled, the backdoor is activated and it looks for the user agent header in the incoming request. A user agent header is normally included in web requests to indicate which browser you are using. This is almost the same name as a command carrier, but it's not quite. Make sure the header begins with word Zeradium. In comparison to software vendors that provide bug bounties for responsible disclosure of vulnerabilities so they can be patched, Zeradium refers to a business that buys zero-day exploits in the third-party apps for its own use. The remainder of the header is treated as an order and executed. Remit code execution occurs before of this, allowing the attacker the same rights and privileges as the web server. This backdoor converts PHP into a web shell, a malicious file on the server that can be activated not only by an external attacker but also ordered to execute any system command the attacker desires at the time. In other words, a remote shell of this kind not only allows cyber criminals to run certain commands, but it also allows them to run some commands, allowing them to adjust and change their attack as they go. Because password-based authentication has replaced public key authentication, this attack has become increasingly common. Password-based authentication, in my opinion, is less safe and reliable than public key authentication. I believe we should only allow public key-based authentication for any SSH service on the internet. Password is used when setting up an SSH link. The password is sent to the server when the SSH link is set up with password authentication. Password authentications leave you vulnerable to the traditional method of brute forcing a password. If there are enough users using the C server, it will appear and one of them will choose a bad password. Since it connects a user on one computer to another, key-based authentication is much more secure. In most cases, the key is created for each patron machine user pair. For example, you can only have one identification card, but it can grant you access to a variety of locations. However, passwords can be used to encrypt keys. As a result, the key you create for your local machine will include a password to decrypt it. That is, your local machine will request a password to decrypt your key, send it to the server, and the server will attempt to authenticate. In fact, it does not actually decrypt your key, rather the public key is offset by your password. So, if you use public key, you will have to give the user-machine combination you're trying to attach to a public key. If you are using password, you will need to include a password to the server you are trying to connect to. If you are using public key and password, you will have to choose between providing a public key or a password. As we can see, Alice and Bob have the same passwords. As we can see, they both share the same hash. The attacker could try a dictionary attack. It is not so hard to find a hash function that produces both same results like in Alice and Bob. So we should add salts to our hash function to make them unique regardless of the input content. Decrypt is a password hashing function. It is defined in four-stroke attacks. You can see the example in the figure. First of all, we have the hashing algorithm identifier, and then we have the cost factor, and then we can see the salted hash. The incident did not have a large impact. Unlike the recent SolarWinds breach or other supply chain attacks, which backdoors were embedded in the stable releases of software and distributed to end users. However, it caused the PHP Corporation, the company that maintains PHP, to reconsider how it managed its code infrastructure. The impact was not so huge because it noticed and got prevention quickly. Since they are already using GitHub as a mirror, they decided to connect to it entirely. Only development branch of PHP 8.1 is impacted. So, as a conclusion, in Internet services, it is better to use public key authentication. We always need a backup plan, such as third-party services. We need to be aware of all the codes inside our project because backdoors can be a really small piece of code and look like our original codes. We should not be use very old codes and very old technologies to build our system. We can store our passwords using Bcrypt algorithm. Thank you for listening.